Very good morning, class. Yesterday, we have discussed some very important concept known as the relative velocity. And I told you how to calculate the relative velocity of one body with respect to the another body. Right? If you remember, we have discussed the relative velocity concept in one dimension. That is when body moving in a straight line. I've explained to you that whenever we uh, calculate the velocity with respect to some another body, we always have one condition, that the frame, that means the velocity that we are calculating with respect to the another frame must be stationary. Right. Now today we will discuss when the body is moving in two dimension. Right, they are moving in some, like one is moving like this, another moving is like this. Then how can we find the relative velocity of one body with respect to the another? All right, so let us start. Relative velocity in two dimension. Relative velocity in two dimension. Okay. Consider a point O taken at origin. Let's say this is point O. A body A moves to a point A in direction OA, right? And another body B moves like here in the vector OB. The position vector of body A along OA, let's say, is given by SAO. That means this is a distance covered by the body A, and this is, let SBO, this is the position vector of B with respect to the point O. For the ease of understanding, let's consider, let's suppose you and your friend started from a journey from the clock tower, right? So this O point is clock tower. Your friend B moves toward the Rajpur road, right? And you move toward the Chakrata road, right? So that means you both are moving in a different direction. Now after time t, you have reached a point A and B. You can take any 2 points on the Chakrata road as well as the Rajpur road. Let's suppose the person B reaches at the Silver City and the person A reaches at the let's say Natraj Hall, right? Or the Connaught Place. Now at that point, what would be the position vector of A with respect to B? We can find it by joining the position vector of A to the position vector of B, right? This is AB, right? So this position vector is, let's say, SBA. Now can you find the relation between OA, OB and AB? Can you find it? Now compare this diagram with the help of triangular law of vector addition. What was that? That was, if this is vector A and this is vector B, so this will be the resistance, the resultant R. From here, R is equals to A plus B. Alright. Now compare the situation here. The R, you can see here, R is nothing but SBO, A is SAO, and B is SBA, right? So we can write it here from the triangular law of vector addition, from triangular law of vector addition, we can write as OB, vector OB is equals to vector OA plus vector AB, right? So in the place of vector we can replace them with with their quotient vector. So OB, along OB we have SBO, along OA we have SAO, and along AB we have SBA, right? Alright, so what will be SBA here? SBA will be SBO minus SAO. Let's say this is equation number 1. So now we have find the position vector of the body B with respect to body A, but actually we have to find the what? We have to find the relative velocity. We don't have to find the position vector. Now consider in a small interval of time del t. That means you have reached here at, let's suppose, 12 o'clock. You both reach here at 12 o'clock and you keep on moving. So after let's say after 10 minutes, let's say 12:10, you have covered some more distance in this direction, right? Let this distance be del SAO, right? And similarly the B boy also cover some distance here, that will be del SBO, right? So the new position vector will be this. It is also increased by the factor del SBA. See, in simple language, both the person covers some more distance, that is del SA, del SB, and del SBA. So what will be the new position after time t plus del t? This is a position at time t. This is after time t. Now what will be the position after time t plus del t? After time t plus del t. So in this portion the distance is increased, right, by the factor del. So the SBA will become SBA plus del SBA, right, equals to SBO becomes SBO plus del SBO, right, and SAO becomes SAO plus del SAO. Okay, so I'm rubbing it, you can take screenshot. So I'm writing this expression over here also. This is SBA plus del SBA equals to SBO plus del SBO and minus SAO plus del SAO, right? So can we write this expression as SBA plus del SBA equals to SBO minus SAO, and we have taken this and minus this will be plus del SBO minus del LAO, right? Why we have done this? You can see here this term SBO minus SAO is nothing but SBA. So this can be written as, from equation number 1. So from equation number 1, this become SBA plus del SBA, okay, equals to, this will become SBA, right, and plus del SBO minus del SAO. So this is being cancelled. Now we have left with del SBA equals to del SBO minus del SAO. What if we divide this expression with del T? I'm dividing both sides with del T. So what can we give you? This will give you displacement upon time is nothing but velocity. It will give you VBA equals to VB minus VA. So here you got the relative velocity of B with respect to A in vector form, right? So you can find the relative velocity in 2D motion by using the vector formula. So we have calculated the relative velocity of V with respect to A, that was VB minus VA. What if we want to find out the relative velocity of A with respect to B? That is no problem. So here, see, that was VBA. The relative velocity of VB with respect to A, and that is nothing but VB minus VA. Suppose you have to find the relative velocity of A with respect to B, like VAB. No problem then, just subtract the VB. So it will be VA minus VB. But please consider this, that this is not the normal subtraction, this is the vector subtraction, right? So let's see one more case in which two bodies, or we can say two motion, are inclined to each other at an angle theta, right? So relative velocity of two inclined motion, suppose we have, this is, let's say, velocity vector VA, and this is the velocity vector VB, and they are inclined each other at angle theta. Now we have to calculate the relative velocity of A with respect to B. See? So how can we form this diagram? This is VB and this is VA, and the angle is theta here, right? So we have to find relative velocity of A with respect to B. We have to find VAB. VAB can be written as VA minus VB. We have just discussed this. Now, can this expression be written as like this? VA plus minus VB. What does it mean? That means we are adding negative vector of VB into A. And you know that we have discussed the negative vector in the very initial part of the chapter. Negative vector are nothing but they are equal in magnitude but opposite in direction. Suppose this is a vector A, then this will be vector minus A, right? So instead of subtracting VB from VA, we can do one thing, that we can add the negative vector of VB into VA. How can we do that? If this is VB, then what will be VA? It will be on the opposite side, The diagram will become like this. This is VA, no problem. VB was here, so minus VB will be here. This will be minus VB, right? Here it was, angle was theta, so now this angle will become 180 minus theta. Now by the parallelogram law of vector, you can find out the relative velocity VAB. Okay, how can we find the magnitude? Formula was VAB equals to under root of mod of VAB mod of VA square plus mod of VB square, minus VB square, and plus 2VA minus VB cos 180 minus theta, right? This will give you, I am writing here, this will give you under root of VA square plus VB square minus 2VABB cos theta. So this will be the magnitude of VAB. Alright, and if you want to find out this direction alpha, then you know that how to find it alpha. That will be tan alpha equals to sin theta upon VA minus VB cos theta. So that's how we can find out the magnitude as well as direction of this relative velocity. Let's consider one numerical problem from this concept. This is the question number 3 from your exercise notebook. Question is, the velocity of particle moving on a circular path is 5 cm per second towards the north at an instant. After traversing 1/4 of the path, its velocity is 5 cm per second toward east. That means the magnitude of velocity is same, so the direction has been changed. Initially that was toward the north, and now it is toward the east. Indicate the change in the velocity in a vector diagram. Okay, so let's make the vector diagram for this question. I'm rubbing this question. So this kind of question is very, very important from the point of view of exam. Alright, now the particle was moving on a circular path, right? It is moving on a circular path. Initially at any point that was moving in a toward north, right? Obviously there can be 2 points where it can be moved toward north, either it is at this point or at this point. So I'm considering that it is moving here toward north. Let's say this is a point A, and the velocity is VA, right? Then it says that after traversing 1/4 the circle, so obviously 1/4 means the particle reaches that point. This particle is now moving in this direction toward east. Let's say this is point B and this is VB, but the magnitude is same, that is 5 cm per second. Okay, we have mod of VA is equals to mod of VB is nothing but 5 cm per second. Now we have to find out the change in velocity. So what will be change in velocity? Del V, that will be final velocity minus initial velocity. That means VB minus VA. This will be the change. Okay. Now can we write this expression as VB plus minus VA? We have just done this kind of situation in the previous example. So this is VB, right? And we have to add VA here. So initially VA is like this. VA was like this. Okay. What would be minus VB then? Minus VA. See, if this is VA, we can also write VA can be here, right? Okay. So if this is VA, minus VA will be here. This will be minus VA because we have to add VA, VB plus minus VA. So this will be minus VA. Now what will be the resultant? Resultant will be here. This will be resultant according to the parallelogram law. This is del B, right? So the angle between them, theta, is 9 degree. So what will be the magnitude of del B? So mod of del B will be under root of VA square plus VB square. That is 25 plus 25. That is root 50. 7 point something around. And direction, as you can see here, the direction is toward southeast, right? So direction is southeast. So please try some numerical from this concept. This is very, very important concept. In the next video, I will discuss numerical problem and very important topic of this chapter, that is projectile motion. Till that class, thank you so much.